Okay. Alright, so before we start our class, we start with reciting Surah Al-Fatihah. Okay. Alright, so let's start with chapter 1, fluid properties. Okay. So yesterday when I asked what is fluid, all of you think about liquid, right? Liquid. Alright, it's about because it's normal when we say fluid, people might think it's liquid, but it's actually liquid or gas. Solid is not included in fluid. So fluid is divided into two, whether liquid or gas. So we want to study the properties of liquid and gas, right, in chapter 1. Okay, so this is some of motivational quote for all of you, right? So teachers or lecturers, okay, the same, okay. Teachers can open the door, but you yourself, student, must enter it yourself, right? So I hope you understand this. It means that so teacher can make classes, can make tutorial, but if the student itself don't have courage to learn, so you yourself must enter into that class. You must ask, okay, so that the learning will be more enjoyable and memorable for you later. Right? Okay, so what is the objective of chapter 1? Okay, so the objective of chapter 1 is to acquire fundamental, okay, fundamental or we can say as theory lah, okay, theoretical. To acquire fundamental concept of fluid properties, right? So what is the learning outcome? What is the LO, learning outcome? So as I explained yesterday, so at the end of this chapter 1, you as a student should be able to define fluid. What is fluid? You must be able to state the difference, okay, the difference between solid and fluid, right? So solid is not a fluid. So you must know what is the difference between solid and fluid. Next, you must know how to calculate the common fluid property. Okay, when we give some information, so you will know how to use the formula that we will learn later, right? Next is define Newton's law of viscosity relationship between shear stress and shear strain. Okay, this one I will go after this. All right. Okay, so before we go deeper, you must know what is actually fluid mechanics. Okay, so fluid mechanics is a branch of science. Okay, it's actually, for me, it's physics. Okay, a branch of science that deal with static and motion. Okay, static, what is static? Can someone give answer? What do you understand with the word static?
Stationary.
Okay, so it's not moving, right? Okay, it's static there. Motion means it's moving, right? Okay, so we want to study about static and motion of general behavior of fluid, governed by the law of conservation, law of mechanics, thermodynamics. Okay, so for this one, you will learn specifically in CHE 144, okay? Alright. So actually, fluid mechanics, we want to study about the behavior of fluid, okay? We want to study behavior of liquid and gas during their static and during their motion. So means that we want to study when the liquid, for example, static, what happened? When it's in motion, it's moving, what happened? What is the theory behind that? Okay. Okay, so that is fluid mechanics. All right, fluid. as you all know, I think this one during your school you also know about this, right? We have three state of matter, which is solid, liquid, and also gas. So liquid and gas have common characteristic different from solid. Okay, liquid and gas are fluid. Okay, like I said before, liquid and gas are fluid. In contrast to solid, the fluid, when we say they means liquid and gas. Okay, so liquid and gas as a fluid lack the ability to resist deformation. Deformation means change the shape, all right? Deform, okay? Because a fluid cannot resist the deformation force, it moves. It flows under the action of the force. Okay, as you can see here, okay, the fluid, the liquid move following the force. All right, means that when the pipe is moving, the water will also move following the force. All right, when the pipe move to this direction, the fluid will also move to this direction. It will follow where the force come from. All right. So its shape will change continuously if the force is applied. Means that the liquid will not retain its shape, right? When we move, then it will flow and the shape continuously change. All right. A solid, okay, a solid can resist. Sorry, guys. A solid can resist a deformation force while at rest. This force may cause some displacement, but the solid does not continue to move indefinitely. Okay, this one, for example, simple example I give is plasticine. Okay, you imagine a plasticine, so it's a solid, right? So if you don't apply any force, so that the solid won't change the shape. Okay, so I don't know how to draw the plasticine. You imagine, all right? So if you don't apply any force, so that the solid will not change. Okay, it won't change the shape. All right. All right. So this is the summary of the properties of the fluid. So it will flow under the action of such force. Okay. For example, this one. Okay. It will deform continuously for as long as the force applied. Okay, so if the force applied means that this pipe is keep rotating, so then it will deform continuously. The shape will change continuously. Then the fluid also unable to retain any unsupported shape. Alright. So this one, what is a fluid? Okay, a fluid is a substance in the gas or liquid form. Okay, what is the difference, the distinction between solid and fluid? Okay, solid can resist an applied shear by deforming. Okay, stress is proportional to strain. Okay, later I will explain what is a stress and what is a strain. Okay, so fluid, it will deform continuously under applied shear. Stress is proportional to strain rate. Okay, as you can see here, where is, okay. Okay, imagine you have a rubber, okay, this one. Sorry, imagine you have a rubber here, the pink color one, alright. Originally, the rubber is in this, okay, in this shape. But after you have a force we call as shear stress, so the shape will become like this. Okay. Alright. Okay, imagine you have a rubber, then the plate below, this one, the plate below is stationary, means it does not moving. Okay, so when you move the upper plate, the bottom plate is not moving, but the upper plate is moving, right? So if you move the upper plate, your rubber will be deformed from the original shape to this shape. Okay. Where is shear? Okay, this one is shear. Right, as you can see, there is a arrow here. When you give a force, this one we say as force, a parallel, okay, parallel force we call as shear stress. Okay, the symbol is like this, okay, or we call as tau. Okay, we call as tau, shear stress. Shear stress is equal, so this one, shear stress is equal to force that we give to the metal divided by area. Okay, force, area. This one alpha is the shear strain. Okay, so when it say proportional like this, okay, means that the rate of shear stress is proportional to the rate of shear strain. Okay, the shear strain is the angle, as you can see. Okay. Okay, imagine your original shape is like this, right? Then you give a force. A stress here. Then there will be an angle here. From the original to the deformed shape, we have an angle of change. So the angle here we call as shear strain. Right? Okay. Okay, what's more I want to... Alright, so actually I have a video to share. Okay. Share to computers. Okay. Can you all hear the sound?
Yes,
Yes.
madam.
Yes, madam.
Happens when we
Okay.
cut a cake using a knife? In physics, we could say that the cake experiences stress. Usually when we cut a cake, we hold the knife straight and apply the force perpendicular to the surface area. So can you guess what type of stress this is? It is normal stress as the force is acting perpendicular to this area. But what about these cross-sectional areas of the cake? The area on top is not the only area that experiences stress. As we pierce the knife in, this cross-sectional area experiences stress too. It doesn't look too obvious, but it does experience stress. We can also see that the force is not perpendicular to this area. It acts parallel to it as we are pushing the knife straight down. If the force acts parallel to the surface, it exerts shear stress. This stress tries to push the two surfaces away from each other and hence results in plastic deformation. So this is the basic difference between normal stress and shear stress. Normal stress is where the force is acting perpendicular to the area of contact, while shear stress is the force that acts parallel to the area. Let's take another example which explains shear stress better. Here's a beam and assume that it's fixed at its base. If we apply normal force to this cross-sectional area, then we know that the stress experienced by the beam will be normal stress, which is simply given by F over A, where F is the applied force and A is this cross-sectional area. This will result in a normal strain in the beam, which is given by delta L over L, where delta L is the change in length and L is the original length. Now suppose that we apply a force in this direction, parallel to area A. Again, the beam will experience some stress, but this time it will be a shear stress. The equation or formula for shear stress is the same as that of normal stress. Stress is simply the applied force per unit area, whether it's acting perpendicular or parallel to the area. What about the deformation in the beam by shear force? Here the deformation will be something like this. The object is stretched to some extent. Note that the beam is fixed to the base, so this cross-sectional surface will remain where it is, whereas the cross-sections above it will all get displaced to the right by increasing amounts. Now look at the maximum displacement here. Let's call it delta x. We know that this length is L. It's perpendicular to this. Also notice that there's an angle formed here. We can call it theta. With this information in place, let us define what shear strain is. Shear strain is simply equal to tangent of theta. Yes, shear strain is simply the tangent of this angle. But what is tan theta? We know that it's the opposite side over the adjacent side. Here, the length of the opposite side of theta is delta x and length of adjacent side is L. So it's equal to delta x over L. So that's how shear strain is defined. Length of the deformation at its maximum over this perpendicular length.
Alright. Okay, so I hope you can understand what is the shear stress. So the shear stress is when we give the force parallel to the area, right? Compared to normal stress where you give the force perpendicular to the area. Okay? So this is for solid, okay? This is for solid and this is for fluid. Okay, for fluid, you can measure the shear strain. Okay, for fluid, you can measure the shear strain because your fluid, liquid or gas, will continue to deform. Okay, will continue to deform. Mean that the shape will change when you give force. So you can measure the shear strain like solid. Okay, so you have equation which is tau, the shear stress, if equal to force over area and is proportional to your shear strain, but it have a different formula. So this one is actually velocity. V over h. H is the height. All right. V is velocity. H is height. So when you have your fluid, you have liquid or gas, so it have a velocity, right? Means kelajuan or pergerakan of that fluid. Okay. Alright. So this one is just to summarize back. Okay. Stress is defined as force per unit area. Okay, so normal stress, as you see in the video, okay, is a force exerted perpendicular to the surface area. Okay, so it's perpendicular. This one is the normal stress. Okay, perpendicular. If it's parallel or we call as tangent, okay, force exerted parallel or tangent to the surface area. So this one we call as shear stress. Right, so the difference between normal and shear is only the direction of the force. Okay, for normal it's perpendicular, for shear stress is parallel. Right. Alright, so this one is just simple properties. Okay, for liquid, it will have a free surface here. But for gas, of course, it will have not a free surface because a gas can expand. Okay, a gas expand until it encounters the wall of the container and fill the entire available space. Means that gas will doesn't have a free surface, right? Gas cannot form a free surface. Gas or we call as vapor, right? Just a simple explanation. Okay, this one also I think you all have know, right? The configuration of solid, the liquid and the gas. So for gas it's more random motion compared to solid. Okay, so this one is a no slip condition. So actually this one just want to focus, okay, at the bottom of the where your fluid touch your plate, right? No slip condition mean a fluid in direct contact with a solid. So this one the solid lah, the plate. Okay, a fluid in direct contact with a solid stick to the surface due to viscous effect. Okay, what is viscous? What is viscosity? Okay, viscosity mean kelikatan. Okay, in Malay we say as kelikatan, likat lah. Alright. So when your fluid is in direct contact with the solid, it will stick to the surface because of the viscous effect. Okay, so it's responsible for generation of wall shear stress. So the fluid property responsible for the no slip condition is viscosity. So you just want to explain about the viscosity. It happens when the fluid is in contact with your solid here. Okay, so it's okay guys, maybe because you have learned just learn today, so maybe you will get quite confused. So I think it's normal as a student. It means that we cannot absorb all the thing during our class, right? So when you do your revision later, if you don't understand, you can ask, and when you do the revision, inshallah you will understand more. All right? Okay. So this one, as I explained before, the deformation, okay? The deformation from the original shape. Okay, the original shape is like this. So it will deform, okay, to this shape. Right? As you can see the deformation, the dotted line. Alright? Deforming is caused by shearing force. Okay? Force parallel to the area. Okay, which act tangent. Tangentially means parallel, okay? So from A, B, C, D, the shape will change to A, B prime, C prime, D. Okay. So okay, I think this one is just repeating what I have explained before this. Okay, because we want to go faster. Okay, this one also I have explained. Okay. Shear stress are developed when fluid is in motion. Okay, if the particle of the fluid move relative to each other, so they have different velocity, causing the original shear of fluid to become distorted. Right? So this one, the F over A, okay, shear stress, or we call as tau. We have an angle of the shear strain, okay. Shear stress in a moving fluid. Okay, if E, this one refer back to figure 1.1. So this one, okay. So if E is a distance y from AD, then for a small angle for the shear strain, okay, for the shear strain, it will be, okay, this one, y over x. Okay. Alright. Alright. Okay, so x is the distance, y is the height. Okay, go back. Okay, x is the distance, y is the height. Okay. Shear strain, just divide the distance and height. Okay. So a rate of shear strain, when we say rate, it must have a connected with time. Okay. So the shear strain is x over y. So when we say rate of shear strain, we must have component of time, right? So this one just bring t, okay, bring the time up here. So x over t is also equal to u. U is a speed velocity lah, okay, velocity. U is equal to velocity and also equal to x over t. So that's why x over t is changed to u. Alright, so where u is equal to x over t is the velocity of the particle at E. Alright. So the term u over y is the change of velocity and also can be written in differential. Okay, this one I think you have learned in mathematics, right? So if we say as differential, it must have d here. So du over dy. So equation 1.2 is Newton's law of viscosity. Okay, the constant of proportionality is known as the dynamic viscosity of the fluid. So this one, okay, viscosity, okay. Alright, for Newtonian and non-Newtonian fluid, so actually this one just a simple term actually. So the Newtonian fluid, just want to say that fluid that obey Newton's law of viscosity, for which their viscosity has a constant value, they are known as Newtonian fluid. Okay, so this one, Newtonian fluid. So most common fluid fall into this category. For is your shear stress, your tau is proportional. Okay. For which shear stress is linearly related to the velocity of gradient, means that your shear stress is proportional to your shear strain. Okay. Means that if you increase your shear strain, your shear stress will also increase. If you increase more of your shear strain, then your shear stress will also increase. So it's proportional. So the one that have the characteristic is we know as a Newtonian fluid. Okay, Newtonian fluid. Alright, for this one, I will not go deeper. I think you all can read this by your own. Okay, the other fluid. This one is the fluid that does not obey. Fluid which do not obey Newton's law of viscosity are known as non-Newtonian fluid. The one that obey Newton's law we call as Newtonian fluid. Alright, so this is the characteristic. Right. The characteristic and the example. Okay, you can see here tomato ketchup. Okay, so I think this one you can read by your own, and if you don't understand you can ask, right? Because I want to go for the more important formula of density, viscosity. Okay, alright, density. Okay, I think density during school also you have learned, right? So density, or in Malay we say as ketumpatan. Okay, so the density of a substance is the quantity of matter contained in unit volume of the substance. Alright, it can be expressed in 3 different ways. Alright, the first one, it can be expressed in 3 different ways. So the first one you want to look is mass density. Okay, density, mass density, or we call as rho, right? So this is the symbol. Mass density means that mass over volume. Okay, so mass kg over meter cube, right? So the unit kg over meter cube, right? This one is mass liter, but usually we will not use this unit. Okay, normally we will use this unit, kilogram per meter cube. Alright, so typical value at this pressure, okay, and temperature. mass density of water, sorry, okay, mass density of water is 1000 kg per meter cube. So this one should be in your head lah, alright? Density of water 1000 kg per meter cube. Okay, density of water, because this one is a common. So when we say density of water, you should know it's actually 1000 kg per meter cube, and density of air is 1.23 kg per meter cube. Right? So this is the first type of density, mass density. The next is specific weight. Okay, specific weight is like W. Alright, specific weight is defined as the weight per unit volume. Okay, weight per volume. Right, so weight per unit volume is equal to mass per unit volume times G. Okay, so this is the typical values for water. Okay, specific weight for water and specific weight for air. Right, so next we move to the third type of density, which is relative density, or we call as SG. What is SG? Okay, relative density of specific gravity. Alright, so the unit is like this, or not unit, the symbol, okay, is defined as the ratio of the mass density of substance to some standard mass density. So it's actually like this. Right, so the specific gravity is the mass density of a substance divided by mass density of water at 4 degrees Celsius. Okay, so it has no unit, okay, unitless, right, because rho over rho, so we will cancel the unit, so then it's become unitless. Alright. Okay, next we move on to viscosity. Okay, for viscosity we have two types, which is the first one is dynamic viscosity, the second one is kinematic viscosity. Right, so viscosity is the, in Malay we say as kelikatan, right? So the coefficient of dynamic viscosity can be defined as the shear force per unit area. Shear force per unit area is the shear stress lah, right? Required to drag one layer of fluid with unit velocity past another layer a unit distance away from it in the fluid. Okay, so it's actually, okay, this one is the symbol for viscosity, okay? It's equal to shear stress over du dy. So shear stress force over area, this one is velocity, this one is distance. Okay, then you multiply, then you get this one lah, force time over area, or mass over length time. Okay, time multiply with time. Okay, so this one is the unit. So usually viscosity we measure in poise. Okay, or this one is the unit kilogram per meter second or Newton second meter squared. Okay, so this one is a typical value for water. Okay, why you have to know for water, for air? Because you will have to use this one during doing the calculation later. Okay, later you will see how you apply this one. Okay. Alright, kinematic viscosity. So the kinematic viscosity, or the symbol is like V here, is defined as a ratio of viscosity to mass density. Okay, ratio of dynamic viscosity over mass density. So the unit is meter squared second. Meter squared second, right? And is often measured also in Stoke, right? Okay, so this is typical value for water and air. The kinematic viscosity, okay, for water and for air. Right. So in the United States, most measurement use the English system or units, okay, based on foot, pound, okay, Fahrenheit. But most of the world, we will use metric or SI unit, okay. So this is the most common unit lah worldwide, based on meter, kilogram or degree C, okay. Alright. So before we end our class, right? So we just want to do this tutorial, okay? To determine the density, okay? Specific gravity, density, the rho, specific gravity, Sg, and mass of the air in a room whose dimension are 4 meter times 5 meter times 6 meter at 100 kilopascal and 25 degrees C. So this one actually maybe you can't catch up at the first time. So it's okay because actually this one is involve air. Okay. For air, actually you must know for the density of air, it is pressure over RT. Okay, so this one is density. Okay, so you must know this equation. Okay, I didn't explain right before this. So you must know this one. Density of water, of air or gas lah. Air gas, right? So if we deal with gas, we will have the pressure. Okay, pressure over R times T. Okay, so in this case, how much the pressure? Can anyone tell me?
100 kPa.
Yes,
101 kPa.
100 kilopascal over, okay, this one R is not given in the question. Okay, so this one is R, kilopascal meter cube over kg Kelvin. Okay, because we want to have the same unit of pressure and also the gas constant. So we choose the gas constant with unit kilopascal. Okay, so R, our T is 25 degrees C. So anyone know how to change degree C to Kelvin? What should we do?
Plus 270.
Okay, good. Plus 273 K. Okay, then you will get the density. Okay, when you calculate this, you will get your density is 1.17 like that. Okay, kg per meter cube. Okay, so settle for density. So now specific gravity. Okay, specific gravity, if we can, okay. So specific gravity, okay, is the density of the substance divided by density of water at 4 degrees C. We cannot see. Okay. Density of water, 1000. Okay. So, from this you already know, right? The density of water is 1000 kg per meter cube. Alright. So, for specific gravity. Alright. So, you already calculate the density of your substance, your air. So, you have also your density of water, 1000 kg per meter cube. So, you can solve this one. Okay. Rho, oh sorry. Okay, so rho air, density air, okay, density air over density, sorry guys, density H2O. So, density air you already calculate is 1.17 kg per meter cube. So you divide by density of water as I've shown before. Okay, so it's 1000, right? Kg per meter cube. So then if you calculate, you will get the answer 0.0017. Okay, simple, right? Okay. Alright, so we settle for specific gravity. And then the last question, a mass of the air in a room. Okay, mass. So, wait. You know that density is equal to mass over volume. Okay, if you can recall back. Okay, density is equal to mass over volume. Right, so I just apply back this formula to find the mass. Right, so how to find the mass? Mass is equal to, you just bring back the volume here, so is equal to density times volume. So how you want to find the volume from the dimension given?
120.
Okay, so you just multiply lah, 4 meter, 5 meter, 6 meter. Okay, it's given here. Alright, so you will get the volume is 120 meter cube. Alright, then you can solve how much is the mass. Your density is 1.17. Okay, 1.17 kg per meter cube. Unit is important, yeah. When you want to solve for a problem, please put the unit. Alright, because sometimes if your answer is true, correct, but you don't put the unit, maybe you can lose some mark. Okay, so better put the unit. Right, so mass is equal to density times the volume. So the volume we have calculated here, 120 meter cube. So we can cancel here, so we get the mass is 140.4 kg. Alright, settle. So actually, that's all for chapter 1. It's just right, simple. You learn about viscosity, density, the concept of the shear stress, maybe the concept of shear stress and shear strain. Maybe you still have to do the revision, maybe quite confused, right? Because yeah, first time you learn about a new thing, you cannot absorb all. Okay, so that's the function of revision. Okay, you have to look back. All right, so I think that's all. Mana Najiha? All right, so I think that's all for chapter 1. Maybe after you have a look on the slide, okay, on the slide later when you print the slide and you do the revision, maybe you have question to ask, right? Right. All right. Any question, guys, before we end? I think question will come when you do the revision, right? Okay. Najmi, okay, Najmi?
Okay, madam.
Alright. So, semua okay?
Okay, madam.
Okay, madam.
Okay, madam.
Okay.
Okay, madam.
Alright. Okay, so stop.